Hey guys, welcome to another exciting episode of Tech Talk with MMK. Today, let's explore a realm that's currently dominating the software industry landscape, cloud computing. But what is cloud computing? Why is cloud computing skyrocketing in popularity, captivating the attention of tech giants and startups alike? Before we delve into this, let's set the stage with a brief exploration of some fundamental concepts and terminologies. I know most of you might be aware of this, but consider this as laying some groundwork for people who are new to this domain. To begin with, a network is a cluster of interconnected computers capable of sharing data, much like a room full of people sharing ideas. The amalgamation of these networks on a large scale, that is, the interconnection of these networks, is called internet. A packet is defined as the small part of a large message that needs to be sent. Every time a large message is divided into small packets and each packet contains a specific part of that message along with information about that message as its header. Let me give you an example. Consider that you have ordered a large dining table from IKEA. It will not be shipped as a piece, right? It is dismantled and is shipped as several pieces. On each piece, there are some instructions about that piece and where it belongs while fitting. And consider these as headers. Now, how does two computers from different networks communicate with one another? It's like two people from different countries speaking to one another. Like these people need a common language. For computers, they need some common language called protocols. These protocols are rules that allow computers from different networks to communicate via internet. For instance, there is Ethernet for systems within the same network. There are some set of rules for sending packets between systems of various networks, and that's IP, Internet Protocol. Internet Protocol assigns each user with a unique IP address. This IP, while sending the data packets, it also sends a unique IP packet, and this IP packet contains the address of sender as well as the receiver. It's just like a postal mail. So these packets travel through different routes but reach the same destination. To ensure that these packets arrive in order, TCP, Transmission Control Protocol, comes into the picture. TCP is like an assembler, a puzzle assembler that assembles the puzzle sent through mail. So these packets travel through different routes, and IP ensures that these packets reach the destination address, while TCP ensures that these packets are in correct order. Now let's see about some important component that we hear and use every day. Server. Since there are millions of users requesting for data across internet every day, we need some really big machines to serve those millions of requests. Those machines are called servers. These servers are some giant computers stored in some data centers that serve the requests of various desktop computers called as clients. This process is called client-server mechanism. The main components of server includes motherboard, CPU, processor, memory, just like your desktop computer but in a much bigger way. There are different servers like database server, web server, game server, email server, print server, and many more. To meet the demand for data processing, numerous servers are housed together in places called data centers with reliable power sources. These centers also contain telecommunications equipment, security measures, and networking devices to ensure uninterrupted communication and data management. In recent years, there has been an exponential growth in the number of people using various services across the internet. Due to the demand, most of the enterprises are forced to maintain a large number of servers in order to offer services uninterrupted. Once a data center is built, apart from bearing the humongous expenses a data center requires to operate, it becomes even more difficult for the organizations to maintain the infrastructure of that data center, especially when the customer traffic is relatively low. Let me give you an interesting example. Now, consider that you have a restaurant. Its capacity is of 100 tables. During the weekends, consider that around 200 people visit your restaurant, but unfortunately, there is place left for only 100 people. This makes the remaining 100 wait for a long period of time in order to get seated and enjoy your restaurant services. This damages the overall reputation of your restaurant, as customers don't usually tolerate waiting for a longer period of time. In order to meet the demand, if you expand your restaurant by constructing another building that can occupy the remaining 100 as well, your problem is solved during the weekend. But during the weekdays, there won't be 200 people showing up. At maximum, you anticipate around 50 to 80 people to visit your restaurant. Then in order to meet the demand during your weekends, you need to bear the expenditure and maintenance of the other building that you built during the entire week. This will incur great losses in your business. But imagine if you make a deal with the mall or complex your restaurant is situated in. Ask them to give an additional space in their mall, maybe on the terrace or somewhere, for about 100 tables only during the weekend, and you pay the mall a certain amount of rental fee for those 2 days that you use. This is significantly less than constructing and maintaining the new building of 100 tables throughout. Then for the remaining week, you close that additional space and you have your own restaurant of 100 tables, and at maximum you anticipate 80 people a day, which perfectly satisfies your requirement. With this, you enjoy low expenses with great profits. The restaurant here is scalable on demand. This same theory led to the rise of cloud computing. Most of the enterprises experience fluctuations in the number of customer requests that they receive. So instead of completely setting up an entire data center and maintaining its entire infrastructure irrespective of the network inflow, it would be beneficial if the organizations make a deal with some large organizations that already have some existing large data centers. So these small organizations can use the services of those large data centers and pay them based on the demand. And it has many advantages, like it requires very little or no investment at all, and it requires very less workforce. And in future, if the company decides that it don't need that servers, it can just break the rental contract instead of worrying about the entire infrastructure of the servers. Cloud computing is basically divided into two models: deployment model and service model. Deployment model is the way we deploy our application, and it has three options: public cloud, private cloud, and hybrid cloud. Public cloud. It's like servers can use multiple applications of multiple users. Here, you're not the only one using that server. So your application is not the only one that's on the server. So in this case, the only disadvantage is data protection is really less. Now, private cloud. It's just opposite to the public cloud. Here, you will be getting full access to the entire server and you're the only one using that particular server. Now, let's move on to hybrid cloud. It's a mixture of public cloud and private cloud. For example, your organization has a particular website, right? So the research data, research information, and the confidential information of your organization can be stored in the servers on private cloud, whereas the marketing web page, where the contact information of your organization and etc. will be residing, that can be stored on the public cloud as well. So in this way, you can manage both public cloud and private cloud, making it a hybrid cloud combination. Now let's discuss about the service model. Even this has three options: infrastructure as a service, platform as a service, and software as a service. Now let's look into infrastructure as a service. It refers to providing you complete access to the server. You'll be given entire access even to the server's OS. You can download whatever you want and make it do whatever task you want it to do. But when it comes to platform as a service, it gives you a restricted access. You'll be given only a dashboard level access where you are allowed to just upload your application, and the cloud service hosts the application in the server in the desired location, and it takes care of the entire configuration. Whereas when it comes to software as a service, it's completely contrary to infrastructure as a service and platform as a service. In this, you won't be given either access to the server, or even you won't be allowed to upload any file. You'll just be allowed to enjoy the software that is already hosted by the server. It's like your Netflix application. So this is an overview of what cloud computing is. Cloud computing has revolutionized the way data is stored, processed, and accessed. With tech giants like Amazon, Microsoft, and Google leading their way, cloud computing has become indispensable for businesses worldwide. The demand for skilled professionals who can ensure uninterrupted cloud services is soaring. So understanding and harnessing the power of cloud computing will definitely be a key to staying competitive in the future. So that's it for today. Hope you enjoyed the video, and for more of such interesting tech related content, stay tuned and subscribe to Tech Talk with MMK.